All right, let's talk about the diesel engine. It's truly one of the most efficient machines we've ever put into mass production, and it's the absolute workhorse of our entire global economy. But how it works, well, that's a masterpiece of physics. And by the time we're done here, you're going to know exactly why it's such a powerhouse. It really all comes down to one big, fascinating question. How in the world can an engine make so much power when it doesn't even have spark plugs? The answer to that mystery is the key to unlocking everything else about the diesel engine.
And here it is. This is the fundamental difference. A gasoline engine, right? It uses spark ignition. It sucks in a mix of air and fuel, squizzes it, and then zap, a spark plug lights it off. A diesel engine, though, is completely different. It uses what's called compression ignition. It squeezes only air, making that air incredibly hot, and then it injects the fuel. The heat of the air alone is what causes the explosion. That one change, right there, dictates everything that follows. And that big switch to compression ignition completely changes the whole rhythm of how the engine operates, what we call the four-stroke cycle. So here are the 4 steps. First, you've got intake. The piston drops and it pulls in only air. That's so crucial. Then at step 2, compression. The piston flies back up and just squeezes that air like crazy. Third is the power stroke. This is when the fuel is injected, it instantly ignites, and the explosion forces the piston down. And finally, exhaust, where it pushes all the spent gases out. And when we say it squeezes the air, the sheer scale of that compression stroke is just staggering. I mean, look at this. A regular gasoline engine might compress its air-fuel mix about 10 to 1. A diesel engine, it squeezes the air alone as much as 25 to 1. This massive, massive difference in pressure, that is where all the magic happens. And here's the beautiful consequence of that. It's just basic physics, right? When you compress the gas that quickly and that violently, it gets hot, like really, really hot. By squeezing the air that much, a diesel engine creates an environment that's well over 800 degrees Fahrenheit, hot enough to instantly set fuel on fire the moment it hits the air. No spark needed. Okay, so we've got this incredible heat and pressure. How does that actually translate into the raw power and, the famous efficiency that we all associate with diesel engines? Let's connect those dots. It really comes down to 3 main reasons. First, that higher compression ratio we just talked about means it has higher thermal efficiency. It literally wrings more useful energy out of every single drop of fuel. Second, there are no pumping losses. See, gas engines have this thing called a throttle plate that the engine has to suck air past, which wastes energy. A diesel just breathes freely, and it controls its power simply by changing how much fuel it injects. And third, diesel fuel itself just packs more energy per gallon. It's just more energy dense. Now, to get that energy-dense fuel into that cylinder full of superheated air, you need an incredible amount of force. Modern fuel injectors fire that diesel fuel at pressures up to 35,000 pounds per square inch. That pressure literally atomizes the fuel into a microscopic mist that can ignite instantly and completely. But this isn't just about brute force. Over the last couple of decades, some absolutely incredible technology has been layered on top of this basic principle, making diesel engines way more powerful, efficient, and cleaner than ever before. Just take modern fuel injection. It's not one single squirt of fuel anymore. In one combustion event, you can have multiple tiny injections. There's a small pilot injection that smooths everything out and quiets the engine down. Then comes the main injection, which provides all the power. And sometimes there's even a post-injection that's used to help clean up the exhaust system. It's like a finely tuned electronic ballet happening thousands of times a minute. And then, of course, you have turbocharging. A turbo is basically a diesel's best friend. Since the diesel's power is only limited by how much fuel it can completely burn, and you need air to burn fuel, a turbo is the perfect partner. It just crams more air into the cylinder, which means you can inject more fuel, and that's how you get that massive boost in torque. Now, to manage the emission side of things, modern diesels have this whole suite of high-tech cleaning systems. There's exhaust gas recirculation, or EGR, which cools things down to reduce harmful nitrogen oxides. You have the diesel particulate filter, or DPF, which is basically a super fine soot trap. And then there's the selective catalytic reduction system, or SCR, which uses a special fluid to turn what's left into harmless nitrogen and water. So with all this intense pressure and this violent combustion, it means a diesel engine can't be built like just any other engine. Its very design, its DNA is just rooted in strength and endurance.
I mean, to withstand those immense compression forces day in and day out, every single component inside a diesel has to be massively overbuilt. The cylinder walls are thicker, the crankshafts and connecting rods are way stronger, the pistons are more robust. This inherent toughness is exactly why these engines are famous for running for hundreds of thousands, even millions of miles.
And you can see its impact throughout history. From its invention by Rudolf Diesel, who just wanted a more efficient engine, to its complete domination of trucks, trains, and ships in the 20th century, the diesel has become the engine that quite literally moves our world.
So let's bring it all home. When you boil it all down, a diesel engine is, at its very heart, simply a high-compression air pump that's married to an incredibly precise, high-pressure fuel delivery system.
A system that makes a fundamental trade. It gives up the high-revving nature of a gas engine for just immense, load-moving torque, right at low RPMs.
And finally, to answer our first question, it brilliantly trades the complexity of an entire electrical ignition system for the pure, simple, and undeniable physics of compression itself. So the next time you feel that effortless, low-end surge of power from a diesel engine, you'll know exactly what's going on under the hood. You're feeling the perfectly timed harmony of super-compressed, superheated air, atomized fuel, and the raw, unadulterated power of compression ignition. And that, right there, is how a diesel engine works.